Let us see. So, in the last semester, you have discussed about differential equation of order 1. Okay. Even though if it is order 1, we have many varieties of differential equation in order 1. So, we have solved Bernoulli's equation, we have solved exact inexact equation, we have variable separable method, and we have homogeneous method, and linear differential equation is there. So like that we have in the first order itself we have many varieties of differential equations. In the same way, in the second semester we are going to study about nth order linear differential equation. Okay, linear means degree should be 1, order should be anything. Okay, order it may be any finite number. Okay, so any differential equation of the form like this. Okay, so highest derivative plus some constant into lowest derivatives, like that it will continue, equal to some function in x you should get. Okay, so where here a1, a2, a3, those and all you are seeing. a1, a2, a3 and so on up to an minus 1, here an is there. So these are all nothing but some numbers. Okay, so when a1, a2, a3 up to an are some numbers, then we can call this differential equation as linear differential equation of nth order with constant quotients. Okay, so first we are going to solve this kind of equations. Okay, so let us write one more representation of the same equation. So here I am replacing d with d by dx with capital D. We call it as operator. Okay, we call this one as operator. Similarly, second order derivative I am writing it as d square. Third order and fourth order up to nth order I am writing it as power of d. Okay, and if you replace the same values in the given equation, that means in the standard equation, okay, so the standard equation will be converted into notation form like this: d power n plus a1 d power n minus 1 plus a2 d power n minus 2 and so on up to an into y is equal to phi of x. So this is called the notation form of the given differential equation. Okay, so that means finally your differential equation will convert into some function in d. Okay, f of d into y is equal to phi. Suppose if this phi is equal to 0, we call it as homogeneous equation. Okay, so in this equation, if phi of x is equal to 0, we call it as homogeneous equation. Similarly, if phi not equal to 0 and it is having some value, so then we call it as non-homogeneous equation. Okay, so now we are going to study about homogeneous equations as well as non-homogeneous equations. So let us see how does the solution will be for homogeneous differential equations. Okay, so this is a standard form of differential equation. Okay, and he has written in terms of operator form like this. Okay, in operator form, if you replace d with m, we call it as auxiliary equation in terms of m. Okay, so operator you are replacing with some variable. So then the equation is called as auxiliary equation of the given differential equation. Okay, so usually auxiliary equation play a very important role in finding solution of linear differential equation. How will you find means we'll solve the auxiliary equation for some roots. Okay, so whenever you are finding roots, in that you will get many kind of roots. Depends on nature, we will decide how the solution will be. Okay, so The nature of the roots might be here real and distinct. What do you mean by distinct here? Distinct is nothing but different. Okay, not unique number. Okay, you should get different roots for a given differential equation. Okay, so that should be a real number and distinct. That means different. One should not be equal to other. Such kind of roots are called real and distinct. Similarly, one more kind of solutions will get, that is nothing but real and coincident. Okay, real numbers as well as coincident means equal roots. Similarly, we'll get one more kind of roots those are called complex pairs. Complex pairs means you'll get the solutions as complex numbers. Okay. So usually for an auxiliary equation, we'll get these three type of solutions. One is real and distinct, real and coincident, and complex pair. Okay. So let us have an illustration for this. Suppose you got the roots for m as 3, 1, 7. Okay, we call it as real and distinct because no root is repeated. Okay, all are unique. Implies the complementary function. We call the solution for this kind of equation as complementary function, and it is denoted by yc. Okay, so when you got three different numbers, complementary function will be c1 e power m1x plus c2 e power m2x plus c3 e power m3x. So where m1, m2, m3 are your roots. So this is nothing but your m1, this is nothing but your m2, and this is nothing but your m3. So this is one way of writing roots solution for real and distinct roots of a given auxiliary equation. Okay. Similarly, suppose we got the solution like this. M is equal to 2, 2, 2, 1, or all are 2's only. So whenever you got roots for m as like this, all the repeated roots, then the general solution or complementary solution for a given differential equation is yc is equal to, so how many times it is repeated? 3 times. Okay, so we have to generate 3 quotient, that means 3 constant terms which should be like this, like a polynomial. So first I have to start with c1 constant plus c2 into some variable x. Similarly, c3 x square. Okay, so here it is 3 times it is repeated. So you have to write 3 minus 2. That means second degree polynomial you have to write. Okay, so whenever it is repeated for twice, you have to write second degree polynomial. Suppose if it is repeated for 4 times, you have to write cubic polynomial. Similarly, if it is repeated for 5 times, you have to write 4th degree polynomial. Okay, so this one into, what is that repeated root we have to write here? E power 2x. So 2 is repeated, so e power exponential power, that repeated root into x. Okay, in this way we will write solution for repeated roots. Similarly, suppose your m equation is like this, 2 plus or minus 3i. Okay, implies this is called as complex pair. Okay, complex pair as like this, plus or minus 2 plus or minus 3i, or p plus or minus qi, anything like this. Okay, then complementary solution will be written like this. So first e power, what is the real part of this complex number? it is 2. So e power 2x will write into now C1 cos imaginary part you have to write. Imaginary part is 3. So I'll get 3x plus C2 sine 3x. So in this way you have to write the general solution for complex roots. Fine. Is any doubts here? Different roots, repeated roots and complex roots. And way of writing the solutions for that. So we'll get into the problem so that you'll get one clarity. Okay. So working procedure for solving given differential equation of order, higher order, but degree 1. Okay. So first write the given differential equation in terms of notation form. Okay. You need to write the given differential equation in notation form. Then replace d with m. We call it as auxiliary equation for it. Similarly, solve for m using different techniques. That may be a synthetic division or a division method, anything. Okay. So based on the nature of the roots, we will decide in what way we have to write the general solution or complementary function. Okay. So here is a table. How can you write the solutions for real and distinct? Similarly, solution for repeated roots and similarly for complex roots. Okay. So let us see how to write the solution for this equation. So what we need to do is solve this equation. So that means first I'll write the given equation as it is: d cube y by dx cube minus 2 into d square y by dx square plus 4 into dy by dx minus 8y equal to 0. Okay, so it implies, write this in terms of notation form. So notation form is d cube minus 2d square plus 4d minus 8y or 8 into y. So don't write y at a time. So d cube by dx cube. So it is nothing but d cube. D square by dx square. So operator for this is d square. Similarly, d by dx can be written as d is equal to 0. So this is notation form. Okay. Now we are replacing operator with some variable m. Okay. So now replace d with m to get auxiliary equation. Okay, so what will be auxiliary equation? M cube minus 2m square plus 4m minus 8, equate this equation to 0. Okay, so implies solve for this equation. How much you'll get? In the first two terms, m square is common, you'll get m minus 2. Plus in this next two terms, 4 is common, you'll get m minus 2. Take m minus 2 common, you'll get m square plus 4 equal to 0. Fine. So now I'll write different roots for the equation. Implies m1 value, I'll get it as 2, and m2, m3 we'll get from this equation. Okay, implies equal to 0 implies m square is equal to minus 4 implies m equal to plus or minus root minus 4. This is nothing but plus or minus 2i. Okay, so we got the solution in terms of complex pair and real number. Okay, how to write the solution is, therefore the required complementary function is so how to write the complementary function? Yc is equal to, first one is distinct root, right? So for distinct root, what you will do? C1 e power m1x. So that means 2x. Okay. Next for complex roots. For complex roots, what I said? First write e power real part. What is the real part for this? 0 plus or minus 2i is there. So real part is 0. So 0x into, here C1 filter already I have used. So you can use C2 cos imaginary part 2 is there. So 2x plus C3 sin 2x. So in this way you have to write the solution. So overall the solution will become C1 e power 2x plus e power 0 is 1, C2 cos 2x plus C3 sin 2x. Fine. Any doubts?
No, sir. So the last step.
Last step. So whenever you got any solutions like this, m equal to p plus or minus qi. Okay, so how to write the solution means yc is equal to e power real part, it is p x, okay, into c1 cos imaginary part, so that means qx plus c2 sin qx. So that's it. Fine.
No, sir.
What's your doubt then?
From there, so that therefore the required complementary function is
Yes.
from there it's
Here only I have explained now how to write the solution. Whenever you get different roots, what I said, yc is equal to c1 e power m1x. Okay, exponential power, whatever the root you got, that number into x. Here, that only I did. This is a different root, m equal to 2 we got. Okay, so that too I have written in terms of exponential form. Fine. Similarly, we got complex pair. So for complex pair, we have to write e power real part of this number into x. Similarly into c2 cos x plus c3 sin x. So this is nothing but your polar form of a complex number. Usually z is equal to x plus iy. If it is a general standard form, then how to write the complex form for this? That means polar form for this, e power r into c1, complex form, r into cos theta plus I sin theta, right? This is a polar form of a complex number. So we have written the solution in terms of polar form here. Where r is nothing but here he has expressed in terms of exponential. Fine. Yes, is that your doubt? Is it clear? Ishran? Okay, we'll go for next one. Next, observe this. So here we have got d cube y by dx cube plus 6 into d square y by dx square plus 11 into dy by dx plus 6y equal to 0. So let us write that equation. D cube y by dx cube plus 6 into d square y by dx square plus 11 into dy by dx plus 6y is equal to 0. First write it in notation form. So d cube plus 6d square plus 11d plus 6y is equal to 0. Okay. So this is your notation form of given differential equation. So it is 6 into y. Okay. Now find the auxiliary equation. Replace this one with n. Okay. So replace d with n. So if you replace d with m, what happens? M cube plus 6m square plus 11m plus 6 equal to 0. So we got a cubic equation. Okay. So how to solve a cubic equation? You might have studied in your PUC. Solving cubic equations or fourth degree equations. What technique you used to use? There is something called synthetic division. Okay. So we have to apply synthetic division method. So how to solve by synthetic division method? So one, that means the quotients of this equation you have to write like power wise. So m cube quotient is 1, m square quotient is 6, m quotient is 11, next constant is 6. Okay. Now put 0 here, start with 0. You need to write one dividend here. How will you find the dividend? Means we'll take one approximate solution for this. Okay. So the approximate solution will be taken trial and error on basis. Okay. So first let us try, and if you get error, then go for next sample. So that means most of the times we'll get the solution in between 1 and -1, 2 and -2, similarly 3 -3, or 1 by 2 minus 1 by 2. Among this set of solutions only, the most of the questions will get the answer. Okay. So that means substitute this each number into this equation, check whether you are getting 0 or not. If you are getting 0, that is the approximate solution for it. Okay. So suppose if I substitute 1, m equal to 1 here, what happens? All are plus terms. You won't get any term 0. Next, I'll make use of minus 1 here. Okay. If I make use of minus 1, what happens? Minus 1 cube plus 6 into minus 1 square plus 11m. 11m in nothing but minus 1 plus 6 equal to 0. So if we add all this, how much you'll get? Minus 1 plus 6 minus 11 plus 6. What happens? 12 minus 12. We are getting minus 1 as a solution for it. So I'll write this minus 1 here. Okay, using this minus 1, I'll reduce this cubic equation into quadratic equation. So how it means? So first add it. How much you'll get? 1 plus 0, it is 1. Now whatever the result you got from addition, multiply with this root. How much you'll get? 1 into minus 1, you'll get minus 1. Again add it. So you'll get 5. Again multiply with minus 1. So you'll get minus 5. Again add it. You'll get 6. 6 into minus 1, you'll get minus 6. Finally, you'll get 0. Okay. If it is the root, then you'll get 0 here. Okay. Here only you can verify. Okay. If you are not getting 0 means the selection is wrong. That means you have did some mistake in calculation while doing the substitution. Okay. So now again we got some quotients 1, 5, 6. So if there are 3 quotient means it's a quadratic equation. Okay, how to write equation means, so my roots are here now is m1 equal to minus 1, m2, m3, m4. Sorry, m2, m3 will get from this equation. M square plus 5m plus 6. So that means highest power quotient you have to give for first number. Next quotient you have to give for second number. Next constant value you have to take last number. Equal to 0 you put. Okay, again find roots for this. How much you'll get? Yes? M square plus 2m plus 3m plus 6 equal to 0. I hope you know how to solve this, right? Quadratic equation. So you have to multiply highest power number into constant. Okay. So 6 into 1 is 6. Factors for 6 you should get in the middle number. Okay. So 2 and 3 are the factors for 6. And if you add these two, you'll get 5. So if I take m common, you'll get m plus 2. Similarly, plus 3 common, you'll get m plus 2 equal to 0. Next, m plus 2 into m plus 3 you'll get if you take m plus 2 common. Implies m equal to minus 2, m equal to minus 3. Okay, so first you got m1 equal to minus 1. Next take m2 equal to minus 2 and m3 equal to minus 3. So compare these roots, whether these 3 are equal or not. So if these 3 are not equal, then what I'll do is I'll write the complementary solution. The complementary solution is yc is equal to c1 e power, what is the first root? m1. m1 is minus 1. So minus 1x plus c2 e power, how much? Second root minus 2x plus C3 e power minus 3x. So in this way you have to write complementary solution. Fine, getting? Yes. These are all distinct roots. That's why we have to write sum of all these roots. Yes. Getting?
Sir, yes, sir.
Hmm? You may get a doubt why
Yes,
you
sir.
have to write e power something into x only. Suppose here e power minus 1 x is there.
Sir, how did you
Okay.
take that m square plus 5m plus 6, sir?
M square. These I have extracted from cubic equation only, na, this one. These quotients I have extracted from cubic equation. Finally, we got quotients converted into 3 numbers. So 1 degree has been reduced here. So whatever the remaining equation is quadratic equation. 3 terms are there. So 3 minus 1 means 2. So that means it's a quadratic equation. So m square quotient must be 1, m quotient must be 5 and constant must be 6. We have reversely have written the equation. That's it. In synthetic division, what you'll do? You'll reduce the higher order differential equation into, higher order equation into lower degree equation, right? Cubic equation you'll convert into multiplication of linear root into quadratic equation. That only I did here. So this is the quotient of m square, this is the quotient of m, and this is quotient of constant. Fine.
Yes, sir, fine. And dividend is M1, right?
Huh? This is m1.
Okay, sir.
Okay. So one more. Why you have to take exponential of that only? Suppose I got m as this much. Why should I take e power something into x? Correct. This may be your doubt. Ishran, that is your doubt, right? E power minus 1. Why should I write like this only? Is it?
Yes, sir.
So what I'll do is I'll substitute this in the place of y. Okay, what happens? Let us check. So this one is equal to, I have taken y is equal to e power minus x. Okay, I am substituting in the given differential equation. What happens? So what is the value of dy by dx from this? Dy by dx is e power minus x into minus 1, right? This is the derivative of y, correct? Similarly, d square y by dx square. Again, you have to differentiate. How much you get? Minus 1 already is there into derivative of e power minus x is again minus 1 e power minus x. Okay, so that is nothing but e power x you'll get. Similarly, d cube y by dx cube. I am finding individually first order derivative, second order derivative and third order derivative. Is equal to, what happens? Again differentiate e power minus x. How much you'll get? Minus 1 into e power minus 6. So substitute all these equations in this equation. Check whether it is satisfying or not. So what happens? First one is minus e power minus 6. Okay. Plus 6 is the quotient into this one e power minus x plus next here 11. So 11 into dy by dx. What is the derivative of y? So I'll get minus e power minus x, right? Plus y. 6 into y. 6 into y value is e power minus 6. Total how much you'll get? If you take e power minus 6 common. So if you take e power minus 6 common, in the first term it is minus 1, second term plus 6, next in third term plus 11, sorry minus 11, next here in the last term you'll get plus 6. E power minus 6. So what is the value? You are getting 0 or not? That means it is satisfying or not? So again, if you replace it, it will satisfy the given differential equation. That's why we'll take like that. Okay. And there is a significance that now we don't simply replace m with d. Okay. So there is a significance. Here we have taken the assume that here your root is nothing but y is equal to e power mx. Based on this assumption, you'll get this auxiliary equation. If you want, we can prove it. Okay. So what happens means, what is the value of dy by dx for this? If I take this as my assumed solution. Okay. So what happens? Dy by dx is how much? M into e power mx, right? Similarly, d square y by dx square is nothing but m square e power mx. Similarly, d cube y by dx cube is equal to how much? M cube e power mx. Correct. So individually I have found, and this I am taking it as estimated solution or approximate solution for it. Now if I replace everything in the given differential equation, so what happens? Let us see. So first term is d cube by dx. So this is nothing but m cube e power mx plus second term is 6 into d square y by dx square. That means m square e power mx plus 11 into m into e power mx plus 6 e power mx. Okay. If you replace if you take e power mx common, what happens? M cube will be in the first term plus 6m square will be in the second term plus 11m will be in the third term plus 6 in the last term. So e power mx. Okay. So what is this actually? This equation only, na? So how will you get this auxiliary equation? Means by taking the assumption of solution as y equal to e power mx. So that's why we'll get replace d with m. Not simply we put like, we don't put simply like replace operator by variable. It won't happen usually. Just for making the topic or the making problem easy, we are not discussing all this part. Okay, so to write the solution easy, just we'll say replace day with m. Usually it is not. We can't directly replace an operator with variable. Okay, so this much theory is there for it. We have to take assumed solution as e power mx. In that intuition, we are taking m with d. We are replacing m with d. And since we got some values for m, so that m value should be quotient of x here. Correct. So that's why we are substituting whatever the roots for m, we are writing in terms of exponential way. Clear? Yes?
Yes, sir.
So that is the reason why we are putting the solutions there like that. So we'll do one more problem so that you'll get better understanding on the topic. So next one is this. Here directly they have given in terms of operator form. So d cube minus 3d square, sorry, minus 3d plus 2 into y equal to 0. Now replace d with m to get the solution or auxiliary equation. So therefore the auxiliary equation is how much? M cube minus 3m plus 2 is equal to 0. So how to write this? Again 1, m cube quotient is 1, m square quotient is not there, you have to take 0, m quotient is minus 3, next 2. Next apply synthetic division to sort out this. So first assumption is what? Either take 1 or minus 1. So I'll select 1. What happens? 1 cube minus 3 into 1 plus 2. How much you'll get? 1 plus 2, it is 3. 3 minus 3, 0. So it is satisfying this equation.
Sir, how 0 came in between?
Where? M square quotient. M square quotient is not there, right? So m square quotient is not there. That's why I'll write 0 into m square. So we got 1 as your solution for this equation. So add it, 1 you'll get, multiply, 1 you'll get, then add it, you'll get 1, again 1, add it, you'll get minus 2, multiply with this, you'll get minus 2, if you add, again 0. So using first equation, first root, I have converted this cubic equation into quadratic equation like this. How to write the quadratic equation like for this? So I can write the roots are m1 equal to 1. Next m2, m3 will get by this equation. How to write this equation? Start from m square. So m square into 1 will get m square plus m quotient is 1. So 1m minus 2 equal to 0. So solve this quadratic equation. So I'll get m square. Middle you should get 2 means the roots for 2 is 2 and 1 only. So plus 2m minus m minus 2 equal to 0. M into m plus 2 minus 1 into m plus 2 will get. So m plus 2 into m minus 1 you'll get equal to 0. So implies m2 is equal to minus 2 will get. Similarly, m3 equal to plus 1 you will get. Okay, but if you check all the three roots, this is equal to m1 also. Correct. So we got two equal roots and one distinct root. Okay, so therefore the complementary function is how much? Yc is equal to, first write distinct root value. So c1 e power minus 2x. Okay, plus what I said here, whenever it is repeated for 2 times, so you have to write first degree polynomial. If it is repeat for 3 times, second degree polynomial. If it repeats for 4 times, cubed degree polynomial. So like that. So it is repeated for twice. We have to write first degree polynomial. That means c2 plus c3x. So it's a first degree polynomial into e power, what is that repeated root? 1x. So like this, you have to write the complementary function. Getting?
Yes, sir.
So like this. So fastly, we'll do this one. D power 4 minus 5d square plus 4 into y equal to 0 is there. So implies auxiliary equation is m power 4 minus 5m square plus 4 is equal to 0. So write the quotients of all the powers. So m power 4 is 1. Quotient of m power 4 is 1. M cube is not there, put 0. Next minus 5m, minus 5. Next m quotient is also not there, put 0. Here 4. Now we have to reduce this into quadratic equation. So it is of degree 4. So if you want to convert it into quadratic equation, you need to find 2 approximate solutions or 2 initial solutions. Okay, so that too amount from 1 minus 1 or 2 minus 2 or 3 minus 3 or 1 by 2 comma minus 2. So substitute 1. What happens? 1 power 4 minus 5 into 1 power 1 square plus 4. 1 plus 4, it is 5 minus 5, 0. So it is satisfying. So m equal to 1 is 1 root. So apply synthetic division for this. You'll get 1 plus 0, it is 1. Next 1 into 1, you'll get 1. 0 plus 1, 1. 1 into 1, 1. Here minus 4 into 1, you get minus 4. Here also minus 4 into 1, you get minus 4, 0. Fine. Next, how many terms are there? 4 terms are there. 4 terms means it's a cubic equation. Okay. So, for cubic equation, again you have to find approximate or initial solution for this. So again put 0. Now 1 already have taken. Next, go for another number. So I'll take minus 1 here. Okay. So if you substitute minus 1. So let us see. If you are getting 0 here at the end, so no need to worry. So minus 1 is a solution for this. Okay. Okay. So first I'll add it 1. So minus 1, you'll get 0 here. Minus 1 into 0, you get 0. Minus 4. Minus 1 into minus 4, you'll get plus 4. If you add 0. So once you got 0 means it is satisfying this equation. Okay. So like this, you'll get two approximates or two initial solutions to convert fourth degree polynomial into quadratic equation. So this time you got 3 terms. So 3 terms means it's a quadratic equation. So the solutions are m1 equal to 1, m2 equal to minus 1, m3 and m4 will get from this equation. So m square plus 0 into m minus 4 equal to 0. So we'll get m square equal to 4 implies m equal to plus or minus root 4, that means 2. So plus or minus 2. So therefore the solutions are m1 equal to 1, m2 equal to minus 1, m3 equal to 2, m4 equal to minus 2. Now all are distinct or equal?
Distinct.
Yes. So all are distinct solutions, real and distinct. So the complementary solution is yc is equal to, how to write the solution? For distinct,
C1
yes, c1
e power
1 into x plus c2 e power minus 1x, c3 e power 2x plus c4 e power minus 2x. So where c1, c2, c3, c4 are all integrating constants. Okay, those are all integrating constants, that's it. Fine, in this way you have to write. And you may get a doubt. So what happens if I write like this? So I don't want to write like this. I want to write in negative to positive. So I'll write c1 e power minus 2x plus c2 e power minus x plus c3 e power 1x plus c4 e power 2x. Okay. Is both are same? Yes?
No, sir.
Both are same only. Because these constants we don't know. It can take any number of things. Okay. These terms are same. Correct. So you can change the order. Okay. So it doesn't matter. So you can change integrating constants. Doesn't matter. But you have to write the solution which should cover all the roots. That's it. So this is also correct. This is also correct. So you can write in this way also. Not a problem. Fine. So here no need to follow the order. So all the roots must be there. That's it.